Interactions Capstone Project by Cameron Baer and Sydney Sabota. How do Newton's laws describe the interactions between objects? An applied force is a force that is applied to an object. For example, when a person kicks a ball, that person is applying a force onto the ball, which creates movement as a result of the kick. The normal force is the support force exerted upon an object. An example of this would be a book resting on a surface. If a book is resting upon a surface, then the surface is exerting an upward force upon the book. The normal force is always perpendicular to the surface. The friction force is the force exerted by a surface which holds an object back and slows it down or prevents it from moving, such as a football that moves across a table or makes an effort to move across it. When a football moves across the surface of a table and begins to slow down, the desk exerts a friction force in the direction opposite to the motion of the football, which prevents it from accelerating. Tension is the force that is transmitted through, for example, a string, when it is pulled tight by forces acting at each end. The tensional force is directed along the string and pulls equally on the parachute and the man falling on either end of the string. Air resistance is a special type of frictional force that acts upon objects such as a skier going downhill at a really fast pace as they travel through the air. The force of air resistance always opposes the motion of the skier. It is most noticeable for objects that travel at high speeds or for objects with large surface areas. The gravitational force is the force in which, for example, the Earth attracts the moon towards it. All objects such as a cat acting upon Earth experience a force of gravity that is directed downward towards the center of the Earth. The force of gravity on a cat on Earth is always equal to the weight of the cat. The spring force is exerted by a spring or elastic material when it pushes or pulls an object attached to it. This can be seen in an animal spring rider at a playground. The spring attached to the ground holds the animal seat, which is attached to the top of it. When a person sits on the animal seat, they are being pulled down or pushed up by the spring. Therefore, the spring force is being exerted onto the person. Mass is measured in kilograms. Mass is the quantitative measure of inertia. Weight is measured in newtons. The weight of a body is the force that causes it to be accelerated downward with the acceleration of gravity, g. This dog is 10 kilograms on Earth, which means that if the dog was moved to Saturn, the dog would have the same mass of 10 kilograms. Due to the different gravitational forces on Earth and Saturn, the dog would weigh more on Saturn. Newton's first law of motion says that an object in motion stays in motion unless another force acts upon it. An object will have balanced forces if it is at rest, moving at constant speed, or falling with terminal velocity. In these different types of situations, the forces acting upon the object will remain equal to each other and will balance out. The net force equation is net force equals 0. The forces are balanced because objects keep on doing what they are doing unless acted upon by an unbalanced force, such as friction or air resistance. For example, if a soccer ball is at rest on the ground, the gravitational force and the normal force, the ground, will both be applying the same amount of force, which will keep the soccer ball in place, and therefore the ball will stay at rest unless another force acts upon it. In this specific situation, the net force will be net force equals normal force minus gravitational force equals 0. Newton's second law of motion relates to the behavior of objects, where all existing forces are not balanced. This law states that an object's acceleration is dependent on two variables, which are the object's mass and the net force acting upon it. The acceleration of an object is directly related to upon the net force acting on the object and inversely related to the mass of the object. As the force acting upon an object increases, the acceleration of the object also increases. As the mass of an object increases, the acceleration of an object decreases. Net force equals mass times acceleration. A box is hanging by a rope with a tension force. When the tension force is increased, the acceleration rate that the object is being pulled up by also increases. The gravitational force is pulling down on the box, while the tension force is pushing up on the box. In this specific situation, the net force equation will be net force equals tension force minus gravitational force equals ma. Newton's third law states that for every action, there is an equal and opposite reaction. This means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object will also equal the size of the forces on the second object. A person is playing soccer and kicks the ball with his foot into the goal. The action force is the person's foot pushing the ball up. The reaction force is the ball pushing the person's foot down. In the second example, a person is pushing a box with their hands to the right. The action force is the person is pushing the box to the right, while the reaction force is the box is pushing the person to the left. Thanks for watching. Hope you enjoyed.